Alright, so this is reviewing our adding and subtracting polynomials. Number one, there was already a plus sign in between them, so we're just simply combining like terms. Start with the 9x cubed. There's a 1x cubed here, so that makes 10x cubed. Then I see that I also have a negative 2x squared. I have a negative 1x squared, so that's going to make negative 3x squared. And then I've got a positive 3x and a negative 3x, which is going to cross out. So I don't even write them, which means 10x cubed minus 3x squared is my final answer. Going over to number 2, this one has that minus sign in between them, which means we're going to have to add the opposite. So change the middle sign to a plus and change all the signs in the other parenthesis. Now we treat it just like we did number 1. So I have a 1c cubed, adding it now to a positive 3c cubed, so that's 4c cubed. Now I've got a negative c squared and a positive c squared, so they're going to cancel. And then I've got a positive 2c being added with a positive 4c, which makes 6c. And there's my final answer for number 2. You should have been checking your answers in class yesterday on the review. If not, make sure that when you have a minute you do that. And we are going to talk now about multiplying polynomials by monomials. Some of this we've actually already done in the last unit, and it's reviewing your exponent rules as well. But today we're going to work on a polynomial being multiplied by a monomial. We're going to jump all the way to page 503 in your workbook. We're going to skip some parts of this, so go ahead and turn to that. And this is actually review. This is what you did in the last module. So when we have two monomials, now we're just putting proper names to them, we're going to multiply the coefficients, and if the bases are the same, then we add their exponents. So we take 2 times negative 3, which is negative 6, x to the 4th times x to the 5th becomes x to the 9th, and negative 6x to the 9th is your answer. Part B, we took 8 times 6, which is 48. Remember that when you have just a variable, there's always that hidden exponent, the invisible one. So the g squared times g to the 1st is g cubed, 2 plus 1. And then the h's multiplied together combine to h to the 8th. And there's your answer. So again, this really should be prior knowledge. So I want you to look at number 4 and number 5. And I want you to answer those two questions and then unpause the video when you're ready to see how your answers compare. So in number 4, if you multiply 2 times 0.5, you get 1. But why is that not the correct product for this problem? And the reason is you add exponents, not multiply. So the correct product should have been g to the 2.5. Number 5, remember that this x over here has an invisible exponent of 1. So what number plus 8 will give you a 1? And that answer is negative 7, because 8 plus negative 7 is a positive 1. Now let's find the products. I want you to go ahead and do all 4 of these problems. Check with a partner as you go through them, and then unpause the video to check them. And again, I'm having you do them on your own because really and truly this is what you covered in the last module. Number 6, you should have multiplied the 12 and 5, which would give you 60. X to the 5th times x to the 4th becomes x to the 9th. So your answer is 60x to the 9th. You should have added the exponent since they both had a base of x. Number 8, you should have multiplied the 6 and 3 to get 18. The a squared times a is a cubed. Don't forget to fill in missing exponents if you need to. And then b to the 5th times b to the 1 tells you it's b to the 6. Going over to 7 and 9. Number 7, the number should have been 24. You should have had 7 a's and 3 b's, because don't forget that invisible exponent of 1 there. Number 9, the 4 and the 9 multiplied make 36. Letters should typically go in alphabetical order. If you didn't put them, that's fine. So I'm going to move the d next, and that becomes d to the 8th. The j squared, there's no other j's, and there's no other k's. So this is technically the correct answer. If you put it as 36k squared, d to the 8th, j squared, that is okay. But we want to start putting them in alphabetical order if you haven't already. So now let's move this on to what our lesson is actually about today, which is when we multiply a polynomial by a monomial. So typically polynomials are more than one monomial. So we're taking one term and multiplying it to several, which means we're going to be using the distributive property. So if you look at letter A, they took the 4, which is a monomial because it's one thing, and they distributed to each term in the polynomial and multiplied. The biggest thing is, since this was just a 4, we multiplied to each of the coefficients. Part B, it wasn't just a number, there was also an x, so we have to remember that this x has an invisible exponent of 1. So while I multiply the 2 to all the big numbers, I need to also multiply that x, which is x times x squared, which is 3. X times x makes x squared, and then an x times that 4 just is an x. So question number 10 says, explain when to distribute and when not to distribute when multiplying monomials and polynomials. Well, we distribute when you multiply a monomial times a polynomial. But you do not distribute when you multiply two monomials. So now let's practice the distributing the monomial to a polynomial. We're going to do number 11 together, and then you're going to do 12 and 13 on your own or with a partner if needed. Now, number 11 is written a little bit differently. They put the first one in parentheses. It's still the exact same as 12 and 13. It's just because they decided there's so much here, they wanted to group it for you. So I'm going to distribute this to each term. So we start with 4 times 5, which is 20. M cubed times m squared, that's m Now to the fifth, 3 plus 2. And then we have n squared times n. Remember, if you need to, fill in the missing exponent of 1. So n squared times n to the first is n cubed. So there's my first term. Now we're taking it to the second term. So 4 times 3, negative 3, so that's a minus 12. The m's, cube and an m is going to make m to the fourth. Again, if you forgot, put in those ones if you need to. And then n squared times that n is going to make n cubed. So now there's the second term. And now we take it all the way to the end. The 2 doesn't have any variables, so we're really just multiplying that 2 with the 4. So that's 4 times negative 2, so that's negative 8. And then bringing along the variables m cubed and n squared. Go ahead and do 12 and 13. And then unpause the video when you're ready to check your answers. Number 12, this time you have the 2a squared to not just 3 terms, but 4 terms. 2a squared times 5b squared. We know the 2 times 5 is 10. Since a squared and b squared aren't the same, we just attach them together and remember alphabetically. If you needed to, you could have inserted in those invisible exponents. So 2a squared times 3ab should have been 6a cubed and then b. Timesing it to that 6a makes 12a cubed. And then taking the 2a squared times the last term, which is 1, is 2a squared. The very last one, we took 3ab to each of the 3 terms. 3ab, and if you needed to, remember the a and the b have exponents of 1, so does that one, and that one, and that one. If you don't need to, that's fine. So 3ab times 2a squared b should be 6a cubed b squared, b times b. Now to the second term, should turn it into an 18a squared b cubed. And then last but not least, the 3 times that 8 is 24. There are no other a, so it stays a. And then the b times the b is b squared. Hopefully you did fine for these 2 problems. The last thing is what we call application, which is just basically working on these with your real world problems, because they happen all the time. We're only going to cover part of this because the other part we'll work on later this year. So we talk about the volume of a box in this problem. Well, the volume of a box we know is V equals length times width times height. Now, one thing we do know is that it's a square base, which means 2 of the sides will be the same. And we want the height to be 3 inches more than the length. So if the length is s, and the height needs to be 3 more than that, then the height is 3 plus s, or s plus 3. Because it's a square, we know that there's 2 s's, so s times s, which is s squared, times the height, that's that length times width times height, and that gives you the s cubed plus 3s squared. And then we'll be doing some evaluating with this. For the number 14, since they've already done the chart for us, if we wanted the volume to be as close as possible to 4,400, then we would want the side length to be 15. So here is our last problem of the day. So David needs a piece of paper where the length is 4 more than the width and the area is as close as possible to 50 inches squared. To the nearest whole inch, what should the measurements be for the piece of paper? Well, we're talking about area. Area of a piece of paper, which is a rectangle, is length times width. We know the length is 4 more than the width, which means the width is just width. So we're multiplying W times 4 plus W to find the area. So I distribute that W, and my area is 4W plus W squared. And you also might have written it as W squared plus 4W. So the area for the piece of paper is 4W plus W squared, and we want the area to be as close to 50 inches as possible. So let's start. We're going to make a little chart here with area. So if the width is 2, let's just start there. Then we would have 4W, 4 times 2, plus 2 squared. So that would be 8 plus 4. Well, that's not anywhere near close to 50, so we know we can definitely go up a higher number than 2. So let's go 6. So I have 4 times 6 plus 6 squared. So that's 24 plus 36. So that would be an area of 60. Well, that's higher than 50, but it's close, so let's see what happens if I plug in 5. So 4 times 5 plus 5 squared. And yes, we're just really doing guess and check here. So I have 20 plus 25, which is 45. Well, that's closer to 50 than 60 is, so I know the width is 5. So if the width is 5, and the length is 4 more than the width, so that would be 4 plus 5, so my length is 9. So these would be the measurements for the piece of paper. So really it's writing the expression and then doing some guessing and checking to figure out the measurements.